We're going to go ahead and talk about surface area of prisms and cylinders. First things first, lateral surface area. That's one of them we're going to talk about. This is going to be the sum of the areas of just the lateral faces. Lateral means side. So we're only finding the sides, not the two bases. And the formula for this, we're going to start off with prisms here. We're going to put LA for lateral surface area is going to be equal to big P little h, and we'll define these in a moment. Your total surface area is all the faces, so not just the sides, okay? And we'll just put SA for, well, this one says TA. A lot of times I'll put SA. It doesn't really matter. It's total. It's all the surface area. It's going to be big P times little h plus 2 times big B. Now, there's a reason these are uppercase and lowercase, okay? We'll talk about that here. Big P, it is going to be perimeter, but it's perimeter of the base, so it's a big section of this. So that's why it's a big letter. So this is going to be perimeter of base. Okay? The H is going to be equal to is going to be the height of the prism. In my opinion, it should have been a big uppercase H, but I don't know. And then we have big B, which is going to be area of the base. Okay? So it's very, very important to understand where the bases are. All right? So for these following prisms, we've got 3 of them. We're going to name the prism first, and then we're going to find its lateral and its total surface area. So the first one here, all of our faces are rectangles. So this is a rectangular prism. Remember to pause it so you can get it all written down. So your lateral surface area is going to be big P, the perimeter of the base, times the height. So let's go find some things real quick. We also know that we're going to have to find big B, because in our total surface area we have big B. So off to the side, we're going to go ahead and we're going to find the perimeter of the base, and we'll use the shaded area as our base. In a rectangular prism, to be completely honest, it does not matter which 2 sides of the bases as long as they are parallel, okay? They don't touch each other. So we can do our perimeter is going to be 2 times the side length of 8 plus 2 times the side length of 6. When we add these together, big P that we're going to substitute in is going to give us 28. Now to find big B, this is simply just going to be base times height, so your 2 dimensions, the 8 times the 6. So big B is going to come out to 48. So we have these to substitute in now. So here, the first blank is us substituting into the formula. The second blank is going to be us putting in the actual answer. So big P, we found out was 28. And the height, well, the height is going to be the one that we have not used yet, and that's going to be right here. Okay, this is going to be height. So we'll type in the 2. When we multiply these together, we're going to end up with 56. It doesn't have units, but it'd be units squared. Area, surface area, squared units. Okay. Next, we have the total surface area, which is going to be big P little h plus 2 big B. So let's substitute in here. Big P, 28, times h is 2, plus 2 times big B was 48. Highly encourage you to pause. Just put that in a calculator all at once. 28 times 2 plus 2 times 48. It'll do order of operations for you. Okay, we're going to come out with 152 units squared. We need to talk about the next one. This is always a struggle with students, so we need to set in stone right now what's happening. On a triangular prism, on all the prisms except for the rectangular prism, it matters which one are your bases. You have to have a certain 2 certain sides that are opposite from each other that are the bases. In a triangular prism, okay, so this is the base, we got a triangle here, so we got triangular prism. Okay, your triangular prism, your prisms in general are going to have 2 parallel sides, and then they're going to have these lateral sides that are going to connect them, okay? So here, what we need to remember with a triangular prism, we're going to put a little asterisk down here because this is going to be extremely important. It kind of rhymes, which makes it nice. We need to remember that the triangular faces are the bases. That's So write that in. Triangular faces are the bases. I'm actually going to move this down so I have some room over there for work. Triangular faces are the bases. This is extremely important because students, if they have a problem like this, they always want to say the base is what's at the bottom. Bases are not always at the bottom, okay? So here we see our two triangles, and the one in the front and the one in the back, okay? They are parallel. No other side, these other three faces, none of them are parallel. They touch. So they can't be faces. So what we're going to do is we're going to kind of lightly shade this triangle, showing that this is our base. So that's what we're going to find big P. That's what we're going to use to find big B. All right? So first to find big P, the perimeter. All we have to do is add the three sides. This over here is 10, meaning this is also 10. Okay? So we have 10 plus the 12. Big P is going to come out to 32. Big B, we need, this is going to be base times height divided by 2. So we have our base right here. It's 12. Okay? So this will be 12. I'm actually going to erase that. The problem is we don't have the height. Okay? So big B in this is little b, little h, okay? Base of the triangle times the height of the triangle divided by 2. What we have to do in this situation is we need to go to the side and we need to figure out what this height is. Remember that the height is going to be perpendicular with the base. So we are going to take out this triangle right here, okay? And we're going to pull it to the side and we're going to use Pythagorean Theorem to find the height. So over here, I'm going to write H in a little triangle symbol so we know it's the height of the triangle. We're going to have to, sorry, let me erase that equal sign. We're going to have to draw in this triangle. Here's our 90 degree. We know the hypotenuse is 10. We are missing the height right here. Okay, it's the height of the triangle. So what about our base? We know the base here is 12, but this is not 12. This is an isosceles isosceles triangle. What this altitude does is it's going to cut this in half. It's cutting that base of the that big triangle in half, giving this 6 and 6. So this leg right here will be 6. So we're going to use this Pythagorean Theorem. I'm going to use h of the triangle squared for A plus b squared, 6 squared, all equal to my hypotenuse, 10 squared. So I'm going to pause it. You need to solve it. You've done Pythagorean Theorem numerous times. Please take a moment, grab the mouse or the little pad, push pause. Solve this on your own, please. So you should have come up with 8 for the height of the triangle. I've also labeled it over here on the triangle. So now we can find big B. All right? Big B, we're going to have the base, the whole base, 12, times the height we just found, 8, divided by 2. Big B is going to end up coming out to 48. So now we can go substitute in for our formulas. This is the easy part once we have everything. Lateral surface area. Perimeter of base times height. Let's plug in. Perimeter of base, 32, times the height. Well, the height is actually what connects your two triangle faces. Okay? So triangular faces are always the bases. Should actually put R. Forgot the always. Sorry, guys. I'm going to draw it right in always. The triangular faces are always the bases. So the path that connects these two bases is the height. Height is, if you lay down, your height's still the same. Okay? So this is just it laying down, basically. So your height right here is going to be 4. We multiply these, we're going to get 128 units squared. So let's take a look at our total surface area, and honestly we're using the exact same formula. Perimeter of base times height plus 2 times area of base. And I encourage you to pause it, substitute it on your own, see what you got, because all you got to do is plug these numbers in now. That's all you got to do. So here we'll have 32 times 4, or perimeter base, times height, plus 2 times the area of the base, 48. We multiply all of these together, we should get 224 units squared. Okay? Your total surface area will always be more than your lateral. If you end up with less, you've made a mistake somewhere. Okay? Let's take a look at this next one. If we take a look at the base, okay, your base, this time is on the bottom, is a trapezoid. So this is a trapezoidal prism. Fun, right? So here, write in trapezoidal prism. I'm going to go ahead and write in my formulas now while I'm here. Lateral surface area, perimeter base times height. Total surface area, perimeter times height plus 2 times area base. So, let's go find some things here. All right? Our height of the prism is right here, connecting the two trapezoids together. All right? So here we've got height of prism. Now let's go and go back up to our triangle one and write that same thing in. Height of prism. Squeeze it in there. Good. So we have H in both of these. Let's go find big P and let's go find big B, perimeter of the base and area of the base. Well, your perimeter of the base isn't going to be hard. We have all 4 sides. We have 12 plus 5 plus 6 plus the other 5. So big P is going to come out to a total of 28. Now big B. Area of a trapezoid, we need to remember, is going to be base 1 plus base 2, in parentheses on the top, times the height, all divided by 2. So we need to find all these different pieces. Well, base 1, remember base 1 and base 2, doesn't matter which one's which. Okay? Problem is we don't have our height right here. Okay? So again, we're going to have to use this right triangle right here to use Pythagorean Theorem. Well, we got the hypotenuse. What about this leg over here? All right, guys, watch this. We've got all the way across is 12. From here to here, this area right here, this little rectangle, from here to here, look at what I'm pointing at. Here to here, here to here, here to here. This is 6, right? Because it says it right here. Well, we take 6 away from 12, we have 6 left that we have to divvy between these two. How do I know they're the same? Because the legs are the same. So we take 6 away from 12, we're going to get 6. And we need to split that in half, 3 here and 3 here. So now we know this part right here. Okay, we know that leg. So, again, we're looking for the height. So we use this Pythagorean theorem that we're so great at. We have 5 here for our hypotenuse. We have 3 for one of our legs. And again, I'm going to use H. So let's go H squared plus 3 squared equals 5 squared. And if you know your triples, this is the easiest one to remember. You may just be able to figure it out already. I'm going to work those pretty actually, I'm going to pause it. I want you guys to go pause, because I'm please pause it. All right, our height should be 4. All right, so now we have everything we need to plug in for big B. This is the most difficult this gets, all right, when you have to actually find these different parts. So here we'll plug in, and see, we got base 1, 12, plus base 2, 6, in parentheses, times the height we found was 4, all divided by 2. When we solve this through here, 12 plus 6 is going to give me 18. So if 18 times 4 divided by 2, big B, we're going to get 36. So let's go plug into our formulas. Whew, exhausting work. Trust me, when we get to cylinders, you're going to love it. All right, lateral surface area, perimeter of base, we found was 28. The height of the prism, remember, it is the pathway from one base to the other. It's how you get from one base to the other base. 10. Well, if we know our rules about 10, just add a 0. So add a 0 to that 28. We have 280 units squared. All right, so total surface area. Let's take the perimeter of the base, 28, times the height, which was 10, plus 2 times big B, 36. When we take this all together, we're going to wind up with 352. I had to pause it because my answer key said 252. And I remember what I said earlier. If this was 252, how is it less than lateral? So we need to make sure. That's where I red flag went up. I was like, uh-oh, what happened? I actually put 2 instead of 3. And then we got units squared. Let's take a look at cylinders. You're going to like how this goes. Usually you're given pretty much what you need. Okay? The only difference is you may be given diameter and need radius. All right? Lateral surface area, same definition. No need to go over. The only difference here is your lateral face is a curved face. It's what we call a curved face because it is cylindrical. Goes around, all right, with circles. Your formula for lateral surface area is simply going to be 2 pi r h. That's it. Your total surface area is going to be 2 pi r h plus 2 pi r squared. Whoa, that's a lot. But guess what? You just plug the numbers in. That's all you have to do. Remember, we are using the pi symbol, not 3.14. All right? So let's take a look at the first one here. Let's go ahead. We need radius and height. That's all we need for these. Okay, it's all we need. So here, we're checking out our radius. Oh, nice. They gave us a radius, 3. Your height sometimes will be drawn on the outside. Sometimes it'll go down the center. But from one circle to the other circle, those are our faces. That's going to give us our height of 6. So, lateral surface area. We've got 2 pi r h. So, here we go. 2 pi, plug in 3 for r, plug in 6 for h. Okay? We're going to multiply all those together. We end up with 36 pi, which is in terms of pi, and then we go ahead and type in that pi button, or just do 2 pi times 3 times 6 here, all in one step. We're going to wind up with 113.1 inches squared. 6 doesn't have an inch next to it, but 3 does. Total surface area is that long one. 2 pi r h plus, I'm just copying from right here, okay, plus 2 pi r squared. So, let's fill everything in. The 2 and the pi stay. Fill in r, fill in h, plus 2 pi, and we need r squared, so 3 squared. Please don't forget to square that radius. If you do not have the correct answer. Okay? So when we plug all this into the calculator, all together, total surface area, we should get a bigger number. We're going to round to the nearest tenth. We did it on the last one. It doesn't say it in the instructions, but that's what we've been doing. End up with 169.6 inches squared. I really do encourage you to try the others on your own. Seriously, that's all you have to do. Yes, the formulas are long, but all you need is R and H. They're either going to give you the diameter or the radius, and they're going to give you the height. Okay? So please, please, please try it on your own. I'm going to go ahead and write in my formulas first, so I have them right here. Lateral, 2 pi r h. Total, 2 pi r h plus 2 pi r squared. Yes, these will always be given to you. Radius, sweet, they gave it to me. 8. Height, bam. This is it labeled outside, so you can see it both ways here. Inside and outside the cylinder. We have 12. We're going to plug in. Yes, it's going to go fast. 2 pi, that's why I said, I suggest you try this on your own. If you make a mistake, oops it is. Radius of 8 times the height of 12. When we multiply all of this into the calculator, we're going to get 603.2, round to the nearest tenth, inches squared. Total surface area, 2 pi, plug in 8 for radius, 12 for height, plus 2 pi, remembering to square the radius of 8, so 8 squared. We plug all this in, we should get a bigger number, 1005.3 inches squared. Last one, seriously, do it on your own. Okay, the only difference is they didn't give us a radius, all right? Here, the diameter, because it goes all the way across, the diameter is 15, therefore your radius is of 7.5. We don't want the diameter, we want the radius. Your height is listed outside. Again, I like this because it's showing you the cylinder in a different position. Your height will be 18. We're going to go quickly through this. That's why again, pause it, do it on your own. Lateral surface area, 2 pi RH. So we go 2 pi, 7.5 for R, 18 for H. Plug it all in to the nearest tenth, 848.2 millimeters squared. Total surface area, 2 pi RH plus 2 pi R squared. All right, let's substitute in our radius and our height on both on this whole thing. 2 pi, 7.5 for radius, 18 for height, plus 2 pi, 7.5 squared. All into the calculator. Let's see if we get a bigger number. 1,001.7